Example 6 of the annual revenue from the global biometrics market for the years from 2016 and projected through 2025 can be modeled by the function y equals. With x equal to the number of years after 2015 and y, we go a different color, is equal to the revenue in billions of dollars. Okay, so part A wants us to graph this function for x equals 0 to x equals 11. So what is that representing? That's representing our x min and our x max here. So let's get into Desmos. And I still have that last one pulled up. So let's type that in. And let's change our viewing window. So we need to go from what? 0 to 11. And it doesn't really tell me what to do with the y. But when I have it in this viewing window here, to make this better, let me go bigger. I've got so much white space up here. I don't need that, right? So if I kind of drag this along, what is the highest number that we have on our y-axis here? It's 16.7 roughly. So when I get into my y, I don't need this to be at 107 when the highest number here is 16.7. So let's change this to maybe 20. Okay, and same thing, I really don't need all of this down here, but that's not as big of a white space, but let me go maybe -2. Okay, so here's a better use of my screen and of that graph. It fits in this viewing window a lot cleaner right here, okay? So example A, check, we have graphed this. Now, for the context of this problem, we don't need this, but let's just kind of talk about it here. And we'll talk about it later. Okay, sorry. Let's go to part B. We'll circle back up to what I want to talk about here for part C. But this says find the global biometrics revenue projected for this or by this model for 2030. Okay, so if I am in 2030 here, okay, one, is this representing my X or my Y? Well, X is to the number of years after 2015, because we're talking about a year. Yeah, we're talking about X. And it wants me to find the global biometrics revenue. I'm finding Y because Y is my revenue here. Now, my X does not equal 2030. X is equal to the number of years after 2015. So here we are saying that X equals 15. Okay, how did I get to that? I'm doing 230, the year I am, minus the year that this is after. Okay, so we're going to go into our second line here and put in X equals 15, and I'm looking for an intersection point. Well, why do I not have an intersection point here? My X is 15 and my X only goes to 11. So you can either zoom out to get to that, or you can mess around with this window. But I kind of like just kind of zooming out because I can see exactly what I need right here. So where is that intersection? That intersection is at 15, 30.623. So we get, I'll go ahead and put that ordered here. No, 15, sorry. 15, 30.623. So to answer this question, word problems need word answers or at least units. Find the global biometrics revenue, and my revenue is in billions of dollars. Oh, I'm writing and you guys can't see what I'm writing, can you? I'm sorry. All right, I just wrote that ordered pair. Okay, if it says find the global biometrics revenue, my revenue is in billions of dollars. Word problems need word answers. So we have 30.623 billion dollars. And let's just go ahead and do billions of dollars. And I'll take away this number sign here, or this money sign here. So I'm going to call that my answer. Okay, so now is your value of part B an interpolation or an extrapolation? So what do those mean? I defined those for you here. And the key word is inside and outside your data set. So an interpolation is making a conclusion about a value that is inside the data set. An extrapolation is now making a prediction about the value that's outside or beyond the data set. Well, I said we would talk about what does x and equals 0 and x equals 11 talk about, but honestly, I don't even really need to do that. If I know that the value that I plugged in here was x equals 15, is that inside this data set or is it outside? Well, that's outside. So this one here is an extrapolation. My original thought was, if we have x equals 0, what year is that talking about? That's talking about the year 2015, because 0 years after 2015 is 2015. And then what year is x equals 11 represent? Well, what is 2015 plus 11? And that would be 2026. So then still that 2030 is outside of those 2 years, but we really don't even need to calculate that because the value I'm plugging in, x equals 15, is outside of those values as well. That's why we had to expand our graph in Desmos. So extrapolation.